We are going to go ahead and hand it over to you, Tim, for your presentation on tour through Azure SQL Database and Azure SQL Database for the, what you got for us. So I think you can go ahead and go from here.
All right, thank you very much. So yeah, we made a quick change at the, well, I guess about 15, 20 minutes or so ago. Can you hear me?
Yeah, I had you muted. Okay. Sorry about that. Go ahead.
No worries. I was just saying that, we made a quick change just maybe 15, 20 minutes ago. So instead of just focusing on Azure SQL Database, which is a product, it's in the platform as a service, we now have other things that are in that platform as a service, such as managed instance, your elastic pools, in the singleton, which is your SQL database, which we'll talk about. There's multiple pricing tiers within there, or offerings. So we now have a serverless and a hyperscale. So we'll touch on those. There's not actual slides in this deck, but we will touch on those. And if we have time, we'll drop over into the Azure portal and kind of look around and see where some of those settings are. So we'll go ahead and jump in. So the goal is a tour through Azure SQL Database, kind of all encompassing what is that platform as a service. I am with SQLSkills. Hopefully you've heard of us. I work with Paul Randall, Kimberly Tripp, Glenn Berry, Aaron Stellato, and Jonathan Cahias. I need to update this. We are actually a Gold Data platform partner, and we've been working with Microsoft for a very long time. A little housekeeping, who we are. You can check us out online, SQLSkills.com. We do a lot of consulting, training, and kind of the takeaway here at the bottom is Paul sends out a newsletter every 2 weeks. Subscribe to that. It's our insider newsletter. It's not a very markety, spammy type newsletter. We have videos that we record that are included in those. We have the little tidbit, some technical aspect. What have we seen that's unique with a customer or something new that we've encountered? So there's technical knowledge in there. There's kind of what's going on within SQLSkills. So it's kind of a fun newsletter. So take a look at it. My contact info, tim@SQLSkills.com. If you're on Twitter, hit me up there. I mostly only use that for SQL Server related stuff, or sometimes I blog about or put stuff out about farming or my fish or pictures of chickens or different things. But that's how you can keep up with me, as well as I blog at SQLSkills.com and timradney.com. All right, so what are we going to talk about? The overall platform as a service, the PaaS, there's a whole lot of as a service things out there, like your infrastructure as a service, software as a service. So now we have this platform as a service. So what does that mean? I'll talk about overall platform as a service benefits. So these are going to be things that you get regardless of whether you're in Azure SQL Database, you're in Managed Instance, you're in Elastic Pool. It's what are things in that overall environment that you get access to. Then we'll dive into what is SQL Database, Elastic Pools, and Managed Instance, and what sets Managed Instance apart. So platform as a service, just think of this as your overall Azure cloud services. It allows us as consumers to focus on building our applications, growing our business, making money, not having to focus on a lot of the infrastructure, the hardware aspects. So your full life cycle, you go build, test, deploy, all those things. Certain components you have auto scale. So you have web services and things like that can just scale up as demand is needed, scale back down when it's not. So that's a huge cost savings to corporations. You don't have to own that infrastructure to be able to do that. You simply subscribe to it, scale up, you pay for compute, and scale back down. And then there's a lot of integrated health and monitoring, as well as load balancers that you can subscribe to. So these are things that cost corporations tens of thousands, hundreds of thousands of dollars to implement and maintain, that are just built into the environment. Compliance and security, it's there. Your predictable performance and pricing, you have guaranteed levels of compute with the node or the service that you're subscribing to. So if you say I need 2 core, X amount of RAM, and your storage is guaranteed to provide X amount of throughput, then that's what you get. The noisy neighbor should never be a problem in this environment. And then it's cloud, so geographically distributed teams. when I work with managed instance, I'm working with teams over in Serbia, SQL database, very similar. It really doesn't matter where we are in the world, we can all access and see the same things. And then the pre-coded application. So your workflow, think of directory services, Azure AD, things like that. It's there. You need to integrate. You simply configure, and you're good to go. So that's one of the areas that really sets Azure apart from other cloud service providers. Is a lot of that integration into the Microsoft ecosystem. It's there. It's all Microsoft. Where if you're somewhere else where you're just purchasing, infrastructure, compute, and then you have to go build, you're having to do all that integration. So this is really what makes Azure kind of shine, and why it keeps just growing exponentially quarter after quarter. So where does SQL Server fit into this platform as a service? Glad you asked. So your SQL database, your Elastic Pools, managed instance, they're all in that platform as a service. So regardless which one you're on, you get to take advantage of those overall benefits. So what are some of those benefits? All right. Dynamic data masking. Now, if you've been working with SQL Server 2016 and above and taken a look at some of the new features, some of these you may recognize. Dynamic data masking was part of 2016, but it was available in Azure SQL Database in the early 2015. Other sessions that I give, like all day stuff, I have when the stuff actually dropped. But it was available in SQL Database well before we ever saw it in a box product. So what this allows us to do is mask how data appears in the result set. So it's not actually changing any physical data. It's just a masking rule. And what's neat about the masking rule is it applies to everyone except who you exclude. And administrators are built in, they're the built-in exclusion group. So with this, if you don't want to expose, full credit card number, social security number, account number, email address, any of those sensitive pieces of data, and it's a third-party application, you can't go and change the data, add your own views, or be able to mask that. This is a masking rule that's applied that doesn't break anything. So now within that application, you can say, unless you're in this group, you're not going to see full account number, email address, things like that. So this really helps you to protect that data a lot better. One of the caveats is if the user is able to query the data directly, you can kind of get around some of this. So think about, Paul keeps a database out there that has our salaries in it. And so I'm going to go and query, and I'm the newest person on the team, and he hired me in at $10 an hour. And I really feel like Jonathan's making at least 20, and we do the same job. All right. So I query Paul's table where he keeps that. So I query salary where last name equals Cahias. Some select star from table where last name equals Cahias. And well, you know what? That salary table, or that hourly rate column, is masked. So I say, well, where hourly rate greater than $10, and Jonathan, he's still there. So select star where greater than, and I see Jonathan's name. Greater than 15, greater than 16, on up. And so I hit 20, and he's still there. I do 21, and he's no longer there. So I know he's between $20 and $21 an hour. I can't see what that actually is, but I can keep querying and narrow that down to how many dollars and cents. Never see the unmasked data, but I'm still able to deduce the same end result. Now in the real world, your applications, your SQL Server reporting services, Power BI report server, whatever it is, you're wanting to mask that data. They don't have direct access to Management Studio or a tool to be able to modify that where clause. So if they can filter the where clause, they can kind of get around it. But most of the time when we're trying to mask this, those aren't those users. This is applications that include data on screens that really shouldn't be there for all users, just some users, and you want to mask it for everyone except for those some users. This allows you to do that really, really easily, and it works really well. So I kind of call it more of a privacy feature than a security feature, but for a lot of your audits and exams, you have to show attempt to protect the data. And this is that attempt. And for the most part, I've seen users benefit from it pretty greatly. You want to take it a step further. So if you have employee data some of your customers are also employees, and you want to restrict who has access to employee data, to only managers, supervisors, and so forth. Row-level security allows you to do that. So now we can restrict who can actually view the data based upon their login or their associated group. So based on who they are, whether or not they can see data. So think of logic, if employee status equals 1 or employee status equals true, that unless you're in this AD group, you can't see that data. So 1 million rows in a table, 200,000 belong to employees. Unsupervised user queries, they see 800,000 rows. Supervisor queries, they see 1 million rows. So that is a lot more restrictive. There are certain things with the row level security, you really need to kind of think through the process. And even with the dynamic data masking, one of the caveats I like to mention with data masking is if you have a numeric value, masking it with a random number can be problematic. So let's say I'm able to query Paul's salary table, and it's just masked with random number, and I look and it says Jonathan makes $1,087 an hour. I'd freak out. Because now it's randomizing versus it being stars or it being X's or it being something that lets me clearly know that it's masked data. I think a lot of the defaults are going to be X's. With row level security, I query, I think I see the entire result set. I'm providing those numbers as the gospel, as actual data, and I'm missing 20% of the table. So you want to make sure that users know that they can't see certain data. All right, let's take that a step further. Always encrypted. This allows you to encrypt the data within the storage engine. So now the data is actually stored encrypted within SQL Server, not TDE where it's encrypted at rest. This is you go and select star from table and salary or social security number comes back and it's GUIDs. It's encrypted data. So unless you have the security key, the encryption key, you're not able to see that plain text data. This gives businesses the ability to kind of protect this data even from DBAs. So if we don't have the encryption key, we too will not see the plain text data. Only the application server, web server, information security team, whoever manages those keys would ever have those keys. So this is a way to truly lock down data. We've never had this before, available in SQL database, and then made it to the box version 2016 and up. You can store the encryption keys in the Azure Key Vault. Once you start dealing with encryption, whether it's backup encryption, always encrypted, you absolutely need key management, because if you lose that key and you need to recover that data, you don't have the key, you don't have the data. Microsoft can't help you. There's not a backdoor, they can't circumvent. So you absolutely want to make sure you have proper key management when you start dealing with those. TDE, it's been around forever, since SQL Server 2008. For SQL database, it is on by default for all new databases. You can turn it off, but it's so lightweight, why not? You get your backups are encrypted, TempDB is encrypted. For your managed instance and all other versions, you have to enable TDE. They now support bring your own key, so you can import your own key. You can do key rotation, all of those things that you're used to with on-premises, you can do in the platform as a service. Also, it supports Azure Key Vault integration. All right, one of my absolute coolest features is threat detection. This, for on-premises, you can subscribe or hire companies like Akamai and others to help you with this. What Microsoft built for their own support in monitoring for Azure, they've exposed to the consumer. So we have access to a lot of the same tools that they built for their own use. So what this allows us to do is to detect and respond to any type of potential threats. So let's say, and this is constantly monitoring and analyzing and seeing what your normal is. So if I'm a Southeast US based company, or maybe I'm just a US based. And yes, occasionally we have, connections coming in from China and the Caribbean and, Africa and Brazil and Canada and all over, because our consumers, they do vacation and they may pull up our website and check whatever. But all of a sudden we see, 10,000 connections coming in from some, foreign location. That's not normal. So we'll get an alert, to tell us, hey, we see this suspicious activity. What would you like to do? Like, shut it off, deny access from that IP range. Because that is not our consumers. That is suspicious, activity. That is hackers. So mitigate that by shutting it off. Internally, we have end users that typically query about 1 gigabyte of data a day. All of a sudden, we see Joe's login coming in from a different IP address, and it's pulling across 40 gigabytes of data. Is that a problem? We don't know. Is Joe, did he move over somewhere and he's working on a migration conversion or something? Or did his account get compromised and somebody's, exploiting our data? We need to investigate that. But how do you detect those things today? Some organizations, they have very complex, systems in place. This, you enable it, you turn it on. Advanced threat detection is a paid service. It costs a whopping $15 per server. So that is $15 per managed instance, $15 per Azure SQL database server, not per database, per server. I believe that's, and with your pools, the databases still reside on a server. So it's $15 per server, $15 per managed instance. That is ridiculously inexpensive. And now they have the security window, so your security pane that has your threat detection and dynamic data masking, vulnerability scans, all of those things kind of from a single pane of glass where you can see your dashboard. This is incredible. Your info security team should absolutely want to subscribe to this and start taking advantage of it. It's so low cost. My opinion, they should have just bundled it in. They're like, if we do that, then it doesn't give it as much credibility. We need to charge a little bit so people tend to put value into it. And I understand that. That's part of the reasons we charge for lunch for SQL Saturdays. Somebody, if they paid $10, they're much more likely to show up to your event than if you give them a free lunch. It's the weirdest thing. If you're paying for it, you tend to, I'm going to get my money's worth and I'm going to show up. I'm going to take a look at it. All right, vulnerability assessment. This was introduced in SQLDB. It's now also included in SQL Server Management Studio. With Management Studio, you go and launch the vulnerability assessment with the PAS products. You can schedule this. So it runs right now every Sunday. At some point, we should see where we can schedule it whatever day of the week that we want and whatever time. But basically, it just goes through. There's a knowledge base, and it's going to compare your system against the knowledge base and provide to you a list of things that don't fit within the knowledge base, or things that it sees are bad or potentially bad. And then you get the report so you can investigate what to do next. It will give you recommendations. Hey, turn this off, turn this on, enable this. And it may be some things that you have to set that are technically against security best practice. Think of a handful of users with sysadmin or whatever it may be, that you can approve that as your baseline. So you're not just being flagged of this every single time it runs to where it's always red and you start to ignore it. You can actually approve this vulnerability as part of your baseline so it stops flagging it. So now the next week or the next month that it runs and you see something that shows up, hey, this is something new, I need to do something with it. So that's really, really cool. Absolutely no reason, this is free, that we shouldn't be taking advantage of this as well. And then of course we have Azure Active Directory integration. I mentioned compliance and security. If you're in a regulated environment, Microsoft has gone through just about every industry certification, compliance-driven cert, and gotten the approval. So the data centers and their policies and procedures and how they handle stuff meets the requirements for PCI a lot of the ISO standards, HIPAA high tech, you still have things you have to do in your environment. Take a look at the Azure Trust Center, look up the certification that you're bound by. And in most of them, they have what they call a matrix. Basically, it's an Excel spreadsheet. It lists out every one of the compliance requirements and talks about what you're responsible for, what they're responsible for, and what's a shared responsibility. So they break it down for you. And a lot of the things, if it's how they handle the hard drives and access into the data center and all of those things, you have no control over that. They've got it covered, so that takes it off your list. If you're a PCI, they're responsible for something like 61.78%. I mean, a ridiculously high number. So that leaves like 30% or something that you're responsible for. And out of those, the majority of those are related to policy and procedure. It's not even anything you really have to do, like from encryption and this, that, and the other. It's what is your procedure for this? What is your documentation for that? And even some of those, it's you got to go and download what Microsoft does and have it on file for you on how hard drives are disposed of. And then some of those other bits are yes, you're responsible for encrypting and not displaying the sensitive data. What do? Well, Microsoft says, hey, that's on you, but here are the tools that you can use to do that. Dynamic data masking, relevant security, always encrypted, TDE. So it's really, really helpful. Also, if you have trouble sleeping, just go pull up one of those documents and start reading. All right, backups. This was one of the hardest things for me to kind of overcome, being a production DBA background, is being a backup and recovery. And when I first started working with Azure SQL Database, I learned that I can no longer take backups. They're handled for me. I'm responsible for the restore, in that any new restore of a Azure SQL database restores to a new name. So I can't overwrite an existing database. I have to restore to new. The reason they don't let you overwrite is then you overwrite from the wrong copy, and then now how do we match backups and all of that? Because I restore a new database and immediately takes a backup. It gets complicated real quick. So it's new name, and that maintains the integrity. Why is it important to know that it restores to a new name? Well, if you're in a singleton pay structure, I'm not part of an elastic pool, I'm paying per database. I restore a new database, that's now a new database that I'm being billed for. So if I restored this to an expensive premium class database, I'm now paying per hour for that. So I want to fix whatever I need to fix, either getting the table out that I dropped or whatever values updated that I overwrote, or rename the messed up production database to database old, rename the restored one to production name, restart my application server, now I'm good, and then maybe drop that bad copy down to a very inexpensive tier for the next few hours, few days, until I know we're good, and then I can go and delete that database. So you just be aware those things exist. Your basic tier, you only have 7 days of backup retention, but your standard premium and your managed instance, you can configure up to 35 days. I think now the default, they still have it as 7 days for your SQL databases and managed instance, and you have to go slide the little slide bar up to the 35 days for backup retention, which I think is ridiculous. I would never, ever want a production database to have anything less than 30 days of backup retention. I would never have one at 7. So I don't get that. I mean, I do, because now they're defaulting to 7, saves them a whole lot of drive space. But the risk there of only being able to go back is, no, it's not worth it. All right, so high availability, all your storage is multiple copies, and all the failure detection and swapping out of disk and all those things, they're handled for you. But if a drive fails, the failover to another drive is automatic. There's nothing for you to do. There's no human involvement. You'll have zero loss of data. Any committed data you're guaranteed is there. With the multiple copies that they have, I want to say the lowest tier, which is your locally redundant storage, so LS or LRS, or I think it's LRS, is 11 nines. that's like 0.000003 milliseconds of downtime per year. I mean, a blink is faster than that. So you're in pretty good shape that any data you write to disk, it's going to be there. All right, and then you have geo-replication available. So all tiers for Azure SQL Database, your storage, you have globally globally redundant and then read globally redundant. You can geo-replicate virtual machines and lots of things that you can do with the geo-replication. So for Azure SQL Database and your Elastic Pool databases, think of a geo-replication as a readable secondary, kind of a replica. It is readable, so you are paying for it, but you can replicate within your tier. So if I'm standard, anywhere within the standard tier, premium, anywhere within the premium tier. So your replica can be a higher class, so more vCore and CPU than your primary. It can also be a lot less, but you are paying for it. It is online, it is readable, so you can offload your reporting to it. And very low estimated recovery time and recovery point objectives. So I don't know how they do it. Very, very fat pipes between the data centers, but very impressive. All right, in-memory support, that is there if you're using it for your premium tier and your business critical for managed instance. One of the really neat things with SQL Database is the auto-tuning capabilities. So this is your automatic force plan, automatic create and drop index. Now for SQL Server 2017 Enterprise Edition, you do have the automatic plan correction that you can enable. So that was kind of spun out, something that we had in SQL Database. It's there in all tiers for SQL DB, and it's there for managed instance, but the automatic kind of force plan is a 2017 Enterprise feature. And I believe there it's called the automatic plan correction versus just the, yeah. All right, and you can, so with SQL Server 2016 with Query Store, we had you have the ability to manually force plan, but again, in SQL Database, you can tell it to automatically. So if it sees in your plan regression, we'll look to see which is the better plan for the overall workload and choose to force it. And that is something you can go and query to look at all force plans that are enabled right then. Oh, one other thing on the automatic index create, it will not create the index if you're under a heavy workload, and it's not the same thing as your dynamic missing index DMV or database tuning advisor. This is actually analyzing the workload, and on one of the copies, like a shadow copy of the database, it will make that change, replay a portion of the workload to see that it gets the advantage that it thought, and then we'll apply it to your production workload and monitor that. And if it sees that it didn't get what it expected, it would roll back that change. And you can't really trick it. It's not a, hey, I run a workload one time or a query one time and it has a missing index that it's going to say, oh, we need this. No, you've got to drive that workload for hours and hours. They haven't published the threshold, but just in testing, it's like 6 to 8 hours before I will see that index creation recommendation. Now your delete has got to be a completely unused or duplicate index that hasn't been touched for 93 days. So that covers your month end, quarter end type index. And then again, if it drops it and then it sees, oh, that was bad, it will roll back that change and put the index back. Any auto-created indexes, if you make a change to the table, such as rename a column, drop a column, add a column, then it will delete that index. And then it will go back through. If your workload needs it again, it will create a similar or additional index. So lots of logic there. And I've got customers with the auto on for create and drop and force plan. All right, Query Store, this should not be something new to you if you're on 2016 and above. Aaron Stellato has a nearly 3-hour Pluralsight course out there and a plethora of blog posts on Query Store. Introduced SQL Database, then 2016, now 2017, 2019. There's a lot of changes to Query Store in 2019 to allow you to control how much it eats and how aggressive it is. It's one of these things that's, in some cases, it's gotten a bad rap because there's been DBAs that have gone and turned Query Store on for 200 databases on an instance that are all very ad hoc, and have seen problems. There have been some legit issues with Query Store and it consuming lots of memory on a very ad hoc system. So it's one of these things, you can turn it on, you can turn it off. When we've helped customers that are on 2016 and above that aren't using Query Store, we've turned it on for 10, 15 minutes, turn it off so it captures some workloads so we can go and see what's going on. It's a tool in your toolbox. I've had people ask, well, when do I know I need to turn on Query Store? Well, if you had that kind of insight into things, you should be playing the lottery. I mean, we don't know when a system's going to go bad, and if you turn Query Store on after the event occurred, well, there's nothing for it to then capture. You might be able to get something out of the default trace, but if you can dial Query Store back where it's not impactful, I mean, it is capturing data, it's logging data, there is a little bit of overhead. How much overhead depends on your system and how you have Query Store configured. So that's why you should go watch the course and read up on Aaron's blogs and take advantage of this. Now, like I said, 2019 offers a lot more knobs to kind of control this thing, but for the platform as a service, it's had those knobs. Microsoft has different settings in place that they control it. For SQL database, Query Store is on by default, and that's what the Query Performance Insight and other tools leverage to provide some of the monitoring in the dashboard. So please do, if you haven't gotten familiar with this, it's one of those hidden gems that you absolutely should learn more about. All right, so SQL database in this platform as a service, this is your cloud relational database as a service. That's the keyword, database. So it's database scoped configuration. You create a database, your schema, your objects, start putting data in, taking data out. We do have elastic database pools. So this is where you have a pool of resources and you can add lots of databases within that pool. Depending on what pool you're in is how many databases, how much storage you have. That allows the databases to scale up and down within that pool of resources. 4 nines of availability built in. So you're guaranteed 4 nines just from the platform. Geo-replication is there. Like I said, that's your readable secondary. When this came out, we didn't have to download a new version of SQL Server Management Studio or any of those things. It is SQL Server on the back end. Yes, it's Azure SQL Database, but it's still SQL Server. So it looks, smells, feels like, interacts like SQL Server. It's just the data source. So SQL command can still connect, integration services, reporting services, all of those things. It's still just a data source. And you can scale up and down with minimal effort. And we talked about the compliance. So what are some differences here? When I said database as a service, that was the key. It is a database. It is not an instance. So there's no SQL Server agent with Azure SQL Database. It's not there, doesn't exist, was never built. You can still use an on-premises SQL Server agent or SQL Server agent on an Azure VM. There are things called an Elastic Job, or I think now it may be called Elastic Agent. And then there's Azure Automation. So those are your 2 cloud services to run your scheduling. A lot of my customers, they have an Azure VM with SQL Server installed. That's their jump box, and they use it for their administration. So that's running all of their ETL jobs. Some have integration services, reporting services there, and they'll leverage SQL Server Agent. Others have migrated to Azure Automation for things. There's no database mail. Just like with Agent, you can use on-premises or database mail on an Azure VM. The number one thing that has stopped some customers from migrating to SQLDB is there's no cross-database query support. This is by design. So Azure SQL Database was built database scoped and in containment. Think of your SaaS, software as a service customers, or those customers that offer service to lots of customers. They need a database per consumer, and no customer needs to be able to talk to one another. So they have to build that isolation, And doing that on an instance of SQL Server can be very complicated because you have DBAs that need to see everything, but now you're trying to design security so customer A can't see customer B, and trying to deal with what's in memory and temp tables, and all of that headache is absolved with Azure SQL Database because that containment is built in by its design. Well, the handicap there for a lot of other applications that have multiple databases is they can't run properly in Azure SQL Database because there's no four-part name, there's no cross-database query support. So a lot of people refer to that as a limitation of SQL Database, when in fact it's one of the #1 design elements and selling features for SQL Database is that containment. Now, you have the SaaS vendor, you have 1,000 databases for your 1,000 customers, and you need to bring all that data in for ETL or for reporting. Elastic Jobs, you can set up to go run and say, grab me the same information from all 1,000 databases and put it over here. So Elastic Jobs can do that, but yeah, the built-in cross-database query, no. And that is a design feature. There's no event notifications. You can set up alert rules for the predefined metrics and notifications that are built in. You can't customize any of those. Trace Profiler doesn't exist with SQL Database. I mean, that was deprecated in 2012, was never built. So, and it's instance level, right? So that's kind of why in a SQL database, it's database scoped. So you use extended events. Any global trace flags, anything requiring SP configure, so you can't change max stop, cost threshold. I mean, ultra database scope configuration, but you can't change your cost threshold for parallelism. Any of those instance level settings, they're off limits. There's no reporting services, integration services. So your cloud service is Power BI and Azure Data Factory. However, if you're still tied to RS/IS, then that's either on premises or an Azure virtual machine. And when I've done a lot of migrations for customers moving to SQL Database, we've focused on database, and then we'd focus on ETL and reporting, and let each one of those be a separate project. And with that, we would just lift and shift their IaaS and RS to an Azure VM, move over the databases, and then slowly start migrating to Power BI or Azure Data Factory. All right, you can't log, ship, mirror, or extend an availability group to an Azure SQL database. Again, it's database scoped. You can to an Azure virtual machine, which is a great kind of a part of the migration strategy. So you can at least through log, ship, or mirror or extend an AG to get your data into the cloud. And then when it's time to cut over, you're not waiting on the file copy, getting that data into the cloud. Now you're just moving from a VM to SQL database. You can set up transactional replication to a SQL database, but that's only one way. So SQL database can be a subscriber, but not a publisher. So once you're up, and that's a great way to cut over because it's near real time. So when you're ready to fail over, you just switch over to it and you're done. But you're still limited to the rules around transactional replication, which means every table has to have a primary key. So depending on your database, you may or may not be able to use transactional replication. So I'll go ahead and point out here for managed instance. Managed instance can be a publisher or subscriber. So that's kind of cool. So now we can have our data in a managed instance and still replicate that back out to on-premises for certain tables that maybe we need to access for whatever reason, ETL, data warehouse, etc. All right, pricing options, you have your database transaction units. This is what we had when SQLDB first launched. So 3 tiers, your basic, standard, premium. Your premium was your high OLTP type workloads where you need more intense IO. You're only going to exist there in the premium tier. Your standard tier is for your standard IO and lower. It's on standard disk, not that premium storage. So your latencies are a bit higher. But for your kind of your departmental type databases, it can probably work out okay in that standard tier. Anything that's IO intensive is going to have to bump up into that premium tier. And then basic, that's 5 DTUs, single web application, for testing, doing dev type stuff. It is not built for any type of medium or higher production workloads. I mean, you can crush it by just doing a select star. All right, when Managed Instance launched, it introduced the vCore pricing model. So now we have general purpose, which is kind of like that standard tier, and then your business critical, which is for your higher IO workloads. So 5,000 IOPS per vCore up to just over 200,000 on your business critical, 500 to 20,000, and I think that's actually like 24,000, a little bit more than 20 on your general purpose. Anywhere from up to 80 vCore, and that's 5.1 gigabyte of RAM per vCore. So at your 80, I think that gets you up to something like 148. No in-memory support in the general purpose, and you do have in-memory for your business critical. And I need to update your general purpose. You can, no, that may just be Managed Instance, is up to 8 terabytes. All right, I'll look that up. Instance level settings, nothing you can change. So TempDB, there's no optimizations, cost threshold, max dot, min, max server memory, all those things that you modify when you install and configure SQL Server, you don't do for SQL database. You create a database, your schema, provision users, and just start using the database. And DBCC free proc cache is not supported. So this is going to be, if you, for whatever reason, need to clear the procedure cache for a database, it's alter database, scoped configuration, free proc cache. So this is where those scoped configurations started coming in, is when SQL database came out, because now we had to start doing things at a database level instead of an instance. How do you tune? Throw hardware at it. Increase the size of the DTU or increase the number of vCores. That's easy. That's costly. I mean, that directly hits a credit card. Or you can tune the workloads. Now, there are a few changes here. So your file statistics, like if you're used to using Paul's script, he references sys.master files. That doesn't exist. So just modify it to use sys.databases. The file stats over time script, very similar. Need to make that change. When it comes to wait stats, since SysDM OS wait stats is at the operating system level, SysDM OS, then that's going to pull at the server level. So your Azure SQL Server, which is a container, not the database. So there's a new DMV with SQL database called SysDM DB wait stats. So simply change Paul's script or whatever script you're using for wait stats from SysDM OS to SysDM DB, and then that will pull back the wait statistics for that database. It even goes a step further in Managed Instance. There's a new DMV that will provide the wait stats per database on an instance. So now we can see, oh, you're looking at CX packet. Well, which database is driving that? Not just, oh, it's the highest weight for the instance. You get to see it per database, which is pretty cool. I documented a lot of these changes for SQL database out on SQLperformance.com. So you can take a look at that. And then Glenn Berry now includes a category of his DMVs just for Azure SQL database. So there's a set of DMV queries just for SQL database. But honestly, outside of that, you tune it like you do any other workload. It's still SQL Server. You can still look at stats, your file stats, wait stats, your worst performing queries, missing indexes. I mean, all of that is the same. And the majority of your scripts that you use on premises today will work with those few changes. So what are use cases for this? Brand new applications, web applications needs a database. You want it to be able to scale up, scale down, be globally redundant and available. I mean, it's great. Your SaaS vendors where you have a database per client, that's really what this was built for. And then there's new projects where you can build your application to point to a single database and maybe leverage multiple schemas instead of the multiple databases. But again, now we have the managed instance. So the whole platform of, the database is there, the backups are handled, the infrastructure, the installation configuration, the patching, all of that is managed. We simply create databases and go from there. We have a version of that, which we'll talk about in a couple of slides, which is manage instance. So what are the elastic pools? So everything I just talked about with a singleton database, that's per database, and you're paying for compute per database. So think of one of your servers today. If you had to assign resources, so how much, if you have 20 core, or let's make it smaller, you have 8 vCPU and 64 gig of RAM on an instance of SQL Server. And you have to determine this database gets 2 core and 8 gig of RAM. This database gets 5.5 core and 23 gig of RAM and so much IO. And you're having to do that per database. Basically service broker. That would be very problematic. I mean, that's a lot of maintenance. That's a lot of sitting there looking at it. And well, now this database has grown and it needs more, and maybe this one needs less. And I mean, that's a full-time job. You don't want to have to do that. So what we can do to make it a lot easier is we determine, okay, we have 16 vCore and 16 times 5.1 gig of RAM. So we have that much memory and RAM and IO available, and we just start putting databases in that pool, and they get to pull from that. And that's what an elastic pool is. You purchase the amount, the number of EDTU or the number of vCore, and the databases can consume more and less. So when their workload ramps up, they can use X amount, and when that dies down, then they free those resources up so the next database can use those. And that's really how an instance operates today. So that's what we're able to do in an elastic pool. And the elastic pool has kind of requirements around it based upon the pool size. So basic pool, 2 gig max storage per database, standard premium, has limits. And then in the vCore model, number of databases per pool. There's no limit as to the number of pools. So as long as you can operate within those guidelines, now you no longer have to worry about micromanaging the individual databases. And when you do a restore, you're restoring into a pool. So you're not now paying for that. If the database isn't being used, all it's consuming out of the pool is the amount of storage that's available to you. So where does this kind of fit in? I mean, if you're managing multiple databases, you're probably going to be better off with a pool of resources, so those can scale up and down within the pool, and you're not having to kind of micromanage that. I had a customer in one of my first IE Azure classes that was not aware that the elastic pools was generally available and was even a thing. And they were paying a premium price or premium tier per client database. And they had an end of day processing that was taking several minutes to run. And they only needed a lot of compute in like the morning startup and the afternoon, kind of close down, whatever processes that were running. And when he heard of this, he kind of checked out from the meeting and was just banging on a keyboard and scribbling notes. And after about an hour or so, just kind of stopped the class, interrupted, and was like, kind of yelled out. It sounded like Doc off Back to the Future. Said, based on my calculations, we could switch to a premium pool and save $4,000 a month. And sure enough, gets back to the office, redoes all the calculations, tells me that they can do this and plans on doing it really, really soon. And then I get an email about a week later saying, oh my gosh, we did this. And then the emails and phone calls just started coming in. And my heart's sinking. I'm getting that knot in my stomach. I'm just waiting. I plan on suing you, kind of next line. It's like everybody wanting, thanking us, whatever you did, thank you. It says now those end of day processes that were taking several minutes were taking seconds. And what it was is they switched to a big premium pool. They're saving $4,000 a month, so $48,000 a year. Their customers are now able to peak above that 125 DTU to several hundred DTU. And so that they have more resources available. So for the DBA, he's not having to micromanage and trying to move some customers to P1, P2, P3, different levels. Everybody's in a big pool. He just manages the overall compute. Customers are ecstatic. They felt like they got a huge improvement and no additional cost to them. Meanwhile, the company's having a fairly significant cost savings. So all of this, when you're dealing with managed instance SQL database, elastic pools, it all becomes a big giant word problem in math. You know, the whole, train starts heading north and one south and Susie's that, I mean, it's a big word problem, but it's math. Certain situations it makes sense to implement a managed instance versus a SQL database versus an elastic pool. And then so far we've talked about, Azure SQL databases, those singleton, even though it's a singleton, it's still an elastic pool. It's still that, database scoped configuration. Maybe I have a database that is rarely ever used, or I have a database that is pretty heavily used, but needs to be able to scale up and scale down because it's completely unpredictable. Even in the elastic pool, I'm having to pay for a set amount of resources, whether I'm using them or not. So if you have that database that you want to say, I want it to automatically scale up and scale down based upon the workload, that's called serverless. So that's a brand new, it's still in preview, but serverless allows you to say, I want to scale down to as low as a half a vCore up to as much as right now 16 vCore. So if the workload comes in, it will automatically scale up, no outage for the scaling up, scaling down. And then you can also tell it if it's been inactive for a certain period of time, just power down. You go to sleep, auto close. And when it goes to sleep, it will wake back up. That first connection, it will ramp back up. But when it's asleep, you're not paying for compute. You're still paying for the storage, but not compute. In compute, when you're scaling up and scaling down, you're paying per second. So you scale up, you're there for 5 minutes or whatever, you're paying per second. And that cost breaks down to like 0.000 something cents per second per core. But I mean, that has a potential of saving you a tremendous amount of money. Now let's go the other route. I have a database that can fit within the 1 to 80 vCore, but it's 20 terabytes in size. It's just got 20 years worth of data. It's massive, it's huge. I want to put it in the cloud, but I'm limited to 4 terabytes in SQL database. Well, hyperscale, right now they're saying you can scale up to 100 terabytes. And that's only because they've only tested it up to 100 terabytes. So if you have a massively large database, yes, you can put it in hyperscale. Once you go hyperscale, you can't bring it back out into the singleton just because of how it has to break the database apart. Basically, you're being divided up into 1 terabyte chunks, kind of sharded out. But it allows you to still 80 vCore up to 100 terabytes in size. And you can spin up, I think right now it's up to 4 readable secondaries, almost real time. So you can scale up, distribute that read workload out, and then scale it back down as needed. So they're getting really, really sophisticated out there. All right, so real quick, what is this managed instance? So introduced at build in spring of 2017, went public preview on March 6, 2018 during the MVP Summit, then generally available at Ignite 2018 for your general purpose, and then SQL Intersection 2018 for the business critical. So it's been fully GA, all tiers, for a full year, a little bit over a year. So what this does, it bridges that gap between your SQL database and on-premises SQL Server or SQL Server on a VM, where we have the full instance look and feel. Your managed instance is instant scoped. So the whole instant scope programming model, so what makes, what do you get when you have a SQL Server instance versus, hey, I'm just provisioning you a database. So this makes it a lot more compatible with the on-premises. And technically, I mean, the goal when they did this was to have 100% surface area compatibility with on-premises. And they've gotten really, really close. There's just a small handful of things like distributed transactions, MSDTC across multiple instances and stuff they're still kind of figuring out. But for the most part, I mean, it works just like on-premises. So backwards compatibility to 100 compat, so SQL Server 2008 databases. You can do a direct migration from SQL Server 2005. And when I say direct migration, you can use, for SQL database, you're using like database migration service, export backpack, import backpack to migrate. But for SQL managed instance, you can back up to Azure Blob Storage and restore from Blob Storage. So native SQL Server backups, it's just got to use Azure Blob Storage as the where you're placing it. So restore from URL, and you can restore a 2005 database. All it's going to do is change the compat level from 9.0 to 100. That is impressive. Think of SQL Server Managed Instance as SQL Server 2019. So your entire instance experience, so all the databases on that instance are on the same server. So cross database query support is fully there. It works. Global temp table support, we finally got that, which made it also available in SQL database. It was not there in the beginning. There is a SQL Server agent built in. Like I said, in SQLDB, there was not. It works, it's there, it's always running, which is unique because you can't stop or restart SQL Server agent. It's always there. It's always on. Which I asked why, because if I'm doing a big maintenance upgrade kind of thing, one thing that I've had to do in the past with on-premises big servers is stop SQL Server agents so they don't have anything firing off, and then just start it back up. And they're like, well, you can just go in and disable the jobs. Well, half the jobs are enabled, half aren't. Now it's complicating things. So there's that weird nuance, but it's always there. It's always running. I think they tied it into like part of the HA. So if it fails, maybe you're going to switch over to another node. But just be aware, you can't stop it. But it's there, it works. Service broker is enabled, works. I mentioned with the replication, it's a publisher or subscriber. So that's cool. Change data capture, CLR, auditing, and database mail. Database mail, when I was doing the testing in the private preview, I went in and used the script that I set it up just using Gmail as the SMTP server, and that even worked. I didn't have to change anything. I just ran my normal script, set up some SQL agent alerts, and fired off a test email, and boom, I've got it to my inbox. Was really cool. Even with all the security and dedicated VPN and all of that, or dedicated VNet, it just worked. We have managed instance auditing, so this tracks everything, writes it to an Azure Blob Storage account. So it's kind of a write once, read many. So for regulatory compliance, all that stuff, they eat that up. TLS is supported, so that encryption in motion. Pricing tiers. So you've heard me mention general purpose and business critical. So your general purpose, that's for your typical kind of departmental on up databases. You have fairly decent storage here. I mean, 500 to 7,500 IOPS per data file. So that's the key here, per data file. And then the size of the file. So your IOPS grow with the storage size. You can kind of cheat the system here a little bit by, if it's a new database that you're creating, looking at the overall size. So you get a minimum of a set number per file, and I can create 4 files and have 4 times the amount of IO if I created one file the same size. So there's ways to kind of manipulate to try to get more throughput. But for the most part, you can also, if you need more throughput, if you have a quarter terabyte file, just make it a terabyte. And now you're in that tier based on size, even though you're 750 gig free space. But you're paying for storage, but you pay for performance. So there's ways to manipulate, and that kind of gets into a whole nother topic of how to performance tune manage instance. But just be aware of the little tidbits I'm dropping out here. So if your IO is per file, more files, more IO. And that's stuff that you can completely configure because this is instance scoped. SQL database, you don't get to pick and choose number of files, where they're at, any of that. Here, you get to choose the number of files. You don't choose the file names. You don't choose the file locations. That's all handled for you. And then your business critical. So here you think of your general purpose. I just went back to this. Your general purpose, your high availability, think of it like virtualization. So where you have a hypervisor and you can vMotion over. So general purpose, your stateful data and stateless are separated. So if something were to happen to a SQL Server service or any of that, your storage would be presented to another node. Zero data loss, you're up in like microseconds, but your buffer pool and all of that are gone. So it's like an immediate failover, but you lose that stateless type data. So be like you ran free proc cache, but it's a blink of an eye, kind of thing for your HA. You switch over to your business critical, your HA is, you have 2 non-readable secondaries and a readable secondary, all through availability groups built in. So that's pretty awesome. Up to 100 databases per instance support. That top number there, 1 terabyte, that should be 4. That was a change from the slide deck. You now have up to 4 terabytes in your business critical. They call it super fast storage. That's the marketing term that Microsoft came up with versus fast storage on your general purpose. Your general purpose is remote SSD. Here on business critical, it's local SSD. So that's where they burst up to the 200,000 IOPS per instance. So pretty fast stuff here. That readable secondary, you're paying for it. Leverage it. So just update your connection to read intent, or enable read intent workload, and offload that read workload to your secondary, and that will decrease the amount of vCores that you need. So if you're on an 8 vCore and you're pressing it out, offload that read workload to your 8 vCore secondary, and you just decreased your requirements on your primary. You can get as low as 4 vCore. That's fairly new, a few months old, to be able to spin up a 4 vCore managed instance. So that kind of helps a lot of customers to get in there, because there's a lot of customers out there that have 2 and 4 vCore virtual machines that they want to move. So that's a great segue into something that's in private or in public preview now, I believe. It's called instance pools for managed instance. Your minimum is 8 vCore. So I have to pay for 8 vCore, but I can carve that up into 4 2 vCore managed instance machines, 2 2s, 1 4, whatever. So it's kind of the Costco model, as you buy the amount of compute, and then you can, within that, spin up kind of micro instances of managed instance. What you can't do is migrate existing managed instances into an instance pool. Maybe that'll change in the future, maybe it won't, don't know. And right now you also can't resize those. Maybe that will change once it gets closer to GA. But right now I could buy 24 vCore and carve that out into 12 2 vCore VMs, which is pretty cool. So that gives organizations the ability to have kind of those smaller managed instances out there. So you can read up on that. With the vCore pricing, it introduced the Azure Hybrid benefit. So this is a benefit for SQL Database on up. It is the vCore pricing model. So a standard edition license is 1 for 1. So 1 standard edition vCore, or 1 standard edition core-based license on premises is 1 general purpose vCore license in the cloud. 1 enterprise core license is 4 vCore using the Azure Hybrid benefit. So for a managed instance, I can take 8 standard edition license, and that's 8 general purpose vCore, or 2 enterprise license, and that's an 8 vCore managed instance. Same with SQL Database. It's 1 standard is 1 general purpose, 1 enterprise is 4 general purpose. So that allows you to bring on-premises license and leverage those and use those in Azure SQL Database, your Elastic Pools, or managed instance. Before that, the DTU pricing, SQL Server license is built into that. So for those early adopters, they either had to reuse those on-premises license or kind of forego those. All right, use case here. Hey, I need more than a singleton database. I need that cross-database query support. I have a lot of legacy applications that the application has 3, 4, 5 databases that all work with it, but I want to get away from managing, patching the OS, patching SQL Server, upgrading SQL Server, managing backups, all of that. I just want to focus on tuning. I want to focus on provisioning and managing, kind of growing the business, not having to deal with all the plumbing. That's where managed instance SQL Database, those kind of come in. But for the managed instance, I need instant scoped. So cross database query, agent, mail, broker, all of that What you didn't see was integration services, reporting services. That's still Power BI or Azure Data Factory or SQL Server on an Azure VM running the legacy IaaS and RS. How does pricing compare here? I've worked with a number of customers that are looking at building out an infrastructure as a service because that's what they're used to. There you patch and build and do everything just like you do on premises. A D16, which is a 16 vCPU with 64 gig of RAM, they needed 6 terabytes of storage, so that was 3 P40 disk, came up to be $6,138, including, that's including the SQL Server license. That's not a bring your own. While a Gen 5 16 vCore with 82 gig of RAM instance with 6 terabytes of storage, not using Azure Hybrid Benefit, was $3,704.88. So not quite half price, but a good third or more less. Plus that 16 vCPU, 64 gig of RAM, for high availability, they would need to spin up another. So they would still have some additional infrastructure cost to have a copy of SQL Server running using log shipping, availability group, database mirroring, something for high availability that they have to manage, where that HA is built in to the Gen 5. I mean, they still get the 4 nines versus the 3 nines for the single VM. So it is very cost effective. Toss in the hybrid benefit. I mean, it should still be a wash, the cost savings between the two, because the licensing should be pretty much the same. So yeah, there's a tangible benefit here. But what it really takes with any migration coming from on-premises is looking at that total cost of ownership. Because today you already have infrastructure in place and any cost moving up. I mean, I try to tell customers, if you're looking to save money by moving to Azure, that's the wrong move. You don't need to be looking at it as, oh, we're going to save money and move, because it's kind of hard to show that. It's we're going to move and we're going to optimize. We're going to cost transference. Now the people that we have on premises, they'll be able to do other things, and the infrastructure, we'll be able to get rid of a bunch of that. But it's not going to be, we're going to move and save $5 million. Because when you get up there and you realize what you have to put in place and actual costs and license and all of that, I mean, it's a weird thing, but I just try to encourage people, don't look at it as, hey, we're going to save a bunch of money. Hopefully, yes, you'll see some cost savings, but when you truly kind of map it out, there's a lot of other costs, the data coming out and whatnot. But anyway, I kind of digressed down a tangent there. All right, some takeaways here. Your SQL database, cost-effective database as a service platform. Your Elastic pools, that's what you use if you have several Azure SQL databases and you don't want to try to micromanage the individual cost per. That's where you just have the pool of resources. Kind of think of it as an instance in relation to, I have an amount of CPU, amount of memory, amount of storage throughput, and all these databases can kind of use and borrow and give back. You can, in that Elastic pool, set limits, so no one database can consume more than X amount of CPU. All right, your managed instance, that's where it kind of bridges the gap between the two, gives you full look, feel of SQL Server on premises, where you have your database mail, service broker, all of those things. Out of all of these, regardless of which platform, you as the DBA or someone in your organization, that's the DBA, is responsible for maintenance. So statistics maintenance, your index maintenance, fragmentation, still a thing, and then running CheckDB. So Microsoft has stated publicly that they do various types of checks, and they do a really, really good job. I've yet to meet anyone that has encountered physical corruption and lost any data. Logical corruption, that's a different story. That's where SQL Server said, hey, I wrote some data, I wrote some extents, and it was a bunch of ones and zeros. User goes to query the data, and it comes back, and they're all zeros. That's not right. That's logical corruption. Is the file corrupt? No. Is the data mush? Yes. We're missing data. It's supposed to be a bunch of ones and zeros. It's all zeros. That's where an extent got blown out. The only thing that's going to find that, I mean, running check disk, physical checks isn't going to find a problem. It's still a logical, consistent disk and file on the disk. What's bad is there was supposed to be data there. It's like when I look at my wallet, there should be cash, but I have 3 kids. There's no cash. I have logical corruption in my wallet. You have logical. The only way you're going to find that is a user querying it or running CheckDB. So it's your choice. You can read what Microsoft has put out there, but every time I've queried them and asked, okay, out of the 3 copies, which one are you querying? Which one are you running CheckDB against? We can't tell you that. Well, how often are you running it? We can't tell you that. Okay, I've only got 35 days of retention. So if I have logical corruption, you may not find it within time. You may never actually technically run CheckDB ever against my database. Well, theoretically, that's possible. Okay, then I'm going to run CheckDB. No, we do it for you. No, you don't. We've established that. So you think about who I work for. Of course, I'm going to tell my customers, yes, you need to run CheckDB. Everyone that I've drawn this out for, and even at Microsoft's centers and pointed this out, they're like, yes, you're probably better off running CheckDB yourself. We all have maintenance windows. And this isn't a maintenance window to run. It's just run it during a time when SQL Server isn't as busy. I mean, it's interrogating every data page. So it is an IO intense, but schedule it, run it, make sure you're doing it. And then if you encounter corruption, then in a SQL database perspective, or in the PAS environment, then that's going to be a ticket to Microsoft saying, all right, I know we have a bad copy. Y'all have to figure out which copy, get rid of it, and then replace it. But yes, you should be running CheckDB. All right, we talked about a lot of stuff around the platform as a service. We've gone a little over an hour from when I started. I think I got y'all at like 3:40. It's now 4:51, so an hour and 10 minutes. Questions? I know you'll have to have some.
Greatly appreciate your time on this, Tim. I don't have a microphone that I can pass around, so let me ask real quick if we got any questions here. So one of the questions, Tim, is how do you handle PowerShell in your managed instances?
Azure Automation is one way. So Azure Automation, your Elastic agent, you can run PowerShell commands from there. Also, any Azure virtual machine or on premises, you can still connect to the database. It's just a data source. So if I drag over a screen real quick, and let me see if I have Zoom it on the desktop. I do. So here I'm connected to a managed instance, and you can see the instance name at the top, tradtest.unique value.database.windows.net. So that's my instance name, so server name. And then I have one database called My Speaking Events. So I would just connect to that through PowerShell, through SQL command, through integration services, reporting services. But with a managed instance, you have no OS level access. So in that case, I mean, if it's something that I need to run PowerShell command to do certain maintenance and it needs to be automated, I'd drop that in a run book in Azure Automation, or just have it running on a SQL agent somewhere that I can launch that. And I really haven't tried any other way on managed instance. To even see here. So, I mean, we could drop something in. That'd be a good test for me to go do something with and see if certain things. I mean, and I would say that maybe certain commands that would through PowerShell would probably work, but other things that are trying to read something else, if it's OS level, might not work. I would have to go, test it out. But full blown, I need to do anything, everything. Yeah, just connect to managed instance as a data source.
You got any other questions here?
Hybrid benefit, are there any limitations to that?
With
Use it for anything.
with the hybrid, read it real quick for me.
Oh, the hybrid benefit?
Mhm.
That basically has to do with licensing, right?
Right. The hybrid benefit is basically just a benefit regarding the licensing. Is that right?
Yes, so it allows you to bring your on-premises license that are covered under software assurance to transfer those to Azure. So let's say I have a customer that has a 8 vCore or 8 vCPU SQL Server instance running on premises. Let's say it's a standard edition with software assurance. And they're moving that entire workload to an Azure SQL managed instance. As long as they're general purpose, they can transfer those 8 vCore and basically trade them back into Microsoft and run that 8 vCore managed instance without having to pay additional SQL Server license. They can no longer use those 8 vCore on premises, but they can use those in the cloud. Otherwise they would be negating. They own those on premise. Try to resell them, but it just allows users to not have to re-incur the SQL Server license costs.
Does it go the other way? Can you take vCore license and bring them down to on-prem? If you had done it one way, can you undo it?
That would be a question for Microsoft licensing. I've never heard anyone that's gone that route. I would think they'd be willing to work with you.
Okay.
But you know how Microsoft license is. I mean, if you're spending millions of dollars, you're sure they'll do whatever. But if you've only spent $20,000 with them, they'll probably stick it to you.
How soon after a CU comes out would it apply that patent?
How recent does it keep up with CU patches coming out?
So that's the thing. In the platform as a service, it's evergreen. It's always. So if I come here and I just do a select at version, you'll see it basically says I'm running SQL Server 2014 RTM. But it's Azure RTM, so it's 12.0.2000.8. That has not changed in many years. But then the last time it was touched was December 4th, 2019. So it's evergreen. It's always updated. But it's not the same as on premises where we have CUs. So things are done here long before we ever see it in a CU. And people always get weird about that too. Is okay, well, what if there's an update that breaks my system? There won't be. I mean, they sit there. I mean, there's millions and millions of SQL databases out there that are running. And typically what they're doing is introducing new code, new fixes, new features. And a lot of those features are opt into. I mean, you go through private preview, public preview, then GA. But they do a really good job of seeing, if we make this change, is it going to potentially break something from looking at all the heuristics of all the data that they collect. So there's yet to be something that has come out that has broke a workload in SQL DB or managed instance. And that's one of the beauties of this is from the OS level, you're up to date. From a SQL Server level, you're up to date. So as a data professional, I'm responsible for provisioning access and making sure that it's running as fast as possible.
Gotcha. Were there any other questions here in room?
Yeah, on backups, the backup retention was what, 30 days or something?
35.
30. How can you expand that if you have like a quarterly or yearly? Is there a backup?
Yes, that's the Azure backup. What do they call it? The retention vault. You can get up to 10 years. The long-term retention is what they call it. So it's just you provision the storage account, and then once you do that and you invoke the long-term retention, then you get to kind of pick and choose. And then typically it's customers that need a monthly full backup. So they need a snapshot at the end of that month and stored monthly, up to 7 or 10 years. And usually it's like financial or healthcare type where they have to be able to go back and prove, well, the decision we made was based upon the data set we had at the time. So they need to be able to go back to that point and show how they came up with their math.
Is the cost, I don't know if Microsoft has a product similar to like Amazon's Glacier storage, or, you know, super cheap storage that you don't need.
Yeah, I mean, their basic storage, I mean, you're paying something like, I mean, it's cents a gigabyte. I mean, so terabyte is, I mean, dollars. I mean, it's really, really inexpensive for your Azure Blob storage. I'll see if I can pull that up real quick and see. And I mean, pretty much everything, they're pretty transparent. If you just do like the Azure pricing calculator, just in a Google Bing search, then it comes up and you can, you know, kind of pick and choose what it is that you're looking for, whether it's, you know, storage or virtual machines, and under like storage accounts, and then view, looking at a pay-as-you-go, yeah, a terabyte's $20.80. And that gives you 100,000 write operations. And then they charge you like 5 cents per 100,000 write operations. I mean, and that's your locally redundant, you know, storage. So if you're getting into like multi-terabyte, you know, and again, think of a backup file. I mean, it's going to be compressed. But if I needed 10 terabytes of storage, I'm looking at about $200 a month. So if you're needing that kind of storage, that's pretty cheap.
Yeah, absolutely. All right. Well, Tim, make sure I'll make sure to send out information in regards to how to get in contact with you if we had any other questions. Would it be something you could also send me the slides as well?
Yes. Yep. I'll save these slides off as a PDF and shoot those over to you right now.
All right. That sounds great. I do appreciate that, Tim. And thank you for speaking. And yeah, thank you very much.
All right. Well, thank you all.